Okay guys, today what we're going to do is write equations in vertex form when given standard form. And we're limiting our scope today to parabolas. Okay, as you remember, vertex form would be y equals a times the quantity x minus h squared plus k, where the vertex is your ordered pair hk. Standard form is y equals ax squared plus bx plus c. And just a quick review of completing the square, CTS, completing the square, because you're going to need that in order to convert your standard form equation into vertex form. Something we might be familiar with is solving equations. X squared plus 2x plus 3 equals 0. Now, back in the day, not that long ago, we would move the 3 over. So you had x squared plus 2x equals negative 3. Then we would take that middle term and divide by 2, and then square our answer. And that's what we would add to both sides of the equation. So in this case, we would take 2, we would divide it by 2, we'd get 1. And 1 squared is 1, so not anything real exciting going on there. Plus 1 plus 1. The whole purpose of doing it is so we could write this trinomial as a binomial squared. And when you factor x squared plus 2x plus 1, you get x plus 1 quantity squared equals negative 2, and then we would solve it from there. So that's kind of the approach we're going to take. Some of these problems will get a little complex, but it'll start off nice and easy. Example number 1, and we're going to use these same values. I want you to see how this process is going to be different from solving. So we just want to rewrite the equation, in vertex form, which is also known, aka transformation form. And they call it transformation form because they're super easy to graph your transformations. When you have something in vertex form, you know you're right and left, you know you're up, down. So it's real easy to graph. All right, f of x equals x squared plus 2x plus 3. Now we're not solving, so this is where it's going to be a little bit different. Take that 3, and rather than moving it to the other side of the equals, you're just going to move it over to the side. Keep it on the same side of the equation. And we're just going to focus on creating a new trinomial here. Take that middle term, 2, we already did the math, divide it by 2, square it, and now this value is your magic number. Now here's where it's going to be dramatically different. You will still add 1 here, but since you're working on the same side of the equation, you are going to subtract 1 from over there, and then you'll simplify it. You need your net change to be on this side of the equation 0. So you added 1, you subtracted 1. My net change is 0. I'm going to take the trinomial, and I'm going to factor it, x plus 1 quantity squared, and I'm going to simplify it here. 3 minus 1, oops, this should be a plus sign. 3 minus 1 is going to give you 2. So the vertex for this equation is going to be negative 1, positive 2. Hopefully it wasn't too confusing. Let's try another one, just like that one. G of x equals x squared plus 8x minus 1. Now our first step at the beginning was to get rid of that number hanging out there so we can focus on building the perfect trinomial. So I'm going to rewrite x squared plus 8x, scooch 1 off to the side. You take your middle term, take b, divide by 2, and then you take that term and square it. Okay, so now this time our magic number is 16. We're going to add 16. We've just made ourselves a perfect square trinomial, and since I added 16, I will also have to subtract 16. Again, the net change here has to be 0. When I go to factor my perfect square trinomial, it will be x plus 4 quantity squared, and then I'm going to tag on at the end negative 17. So my vertex for this one, negative 4, negative 17. Okay, I would say we'll look at one more, example number 3, and after I get it written down, I would suggest you stop the video, try it for yourself, and then come back and see how you did. F of x equals x squared minus 6x plus 3. I'm going to rewrite it, moving the 3 over, take the middle term, divide it by 2, then you square it, add 9 over here, subtract 9 over there, perfect square trinomial, x minus 3 quantity squared, my term at the end, minus 6. My new vertex is 3, negative 6. Okay, now the problems can get a little more complex. That's your best case scenario. Example number 4. F of x equals 2x squared minus 12x plus 14. Now the bad news is I have this 2 hanging out in front. It's really hard to get my perfect square trinomial going with that 2 hanging out in front. I'm still going to move 14 over to the side. 2x squared minus 12x plus 14. But I got to get that 2 out of there. So I'm going to pull out a GCF here. I'm going to leave a 2 on the outside. We have x squared minus 6x. Now and I'm leaving the 14 alone. I don't want to see it. As a matter of fact, I'm just going to close the parentheses now. So I'm going to take my middle term. I'm going to divide by 2 like always. I get negative 3. I'm going to square negative 3, and I get 9. And life is good. I add 9. But here comes the bad news. Bring down your 14. I really didn't add 9. What I added was 2 times 9. So now I'm going to subtract 2 times 9. I'll put a little squiggle in there so hopefully it doesn't get confusing. I'm going to repeat that again because I think it bears repeating. Since we had to factor out a 2 up here, when I think I have my perfect square trinomial going here with the number 9, I do. 9 is good. But I didn't just increase this equation by 9, I increased it by 2 times 9. So now I have to subtract the same value since I am on the same side of the equals. Okay, moving forward, 2 on the outside, we're going to factor the trinomial, x minus 3 quantity squared. And now I have plus 14 minus 18. My final answer, 2 times the quantity x minus 3, and 14 minus 18 will give me a negative 4. So my new vertex, positive 3, negative 4, with an a value of 2. So that's something new. It's a little confusing. It's a little more work. So far it's easy. We're going to have a point in time where the middle value will be odd. And when I have to factor out the 2 out in front, it won't be a perfect fit. And this will give us a fraction. And then we'll have fractions we're squaring. Those are a little more intense. And number 5. Let's try g of x equals 3x squared minus 6x plus 4. That's what we're starting with. Since I have a leading coefficient other than 1, I've got to pull out the 3. So bringing out, make that a little bit bolder, 3 times the quantity x squared minus 2x. I am moving my 4 over, don't even want to think about it right now. I'm working on the perfect trinomial. Take negative 2 divided by 2, you get negative 1. Negative 1 squared, positive 1. So I'm adding 1, but really I added 3 times 1, so now I'm going to subtract 3 times 1. Okay, next step is to factor. Bring down your 3. You can't just get rid of your 3 as if you were solving an equation. That 3 is a very important a value, would change your graph dramatically. The trinomial is going to factor into x minus 1 quantity squared. I have 4 minus 3, so I've got plus 1. My vertex here, it moves 1 to the right and 1 up. Okay, we'll give you some practice problems. Good luck.